Okay, I'm going to go over a problem on intensity. So the problem says that there is a radio wave. Lambda is equal to 0.8 meters, travels in a vacuum along the positive x-axis. So it travels direction s, the point vector is in the positive x-axis. I'm just going to write I hat. The time average intensity, I, is equal to 45 watts per meter squared. What else do we have? We know that at time t equals 0, the electric field at the origin is measured to be directed along the positive y-axis. Blah, 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 blah. So at t equals 0, E is equal to E max. And it is directed along the y-axis. We don't know how much it is. We just know that E is equal to E max, and it is in the j hat direction. And we want dz, the magnetic field at the origin. So this is electric field at x equals 0. We want dz at x equals 0, t t equals 1.5 nanoseconds. Okay, so the easiest way to go about this problem is to make a wave equation. When we have a wave equation, we have a function that we can directly plug stuff in. So before that, so we're going to make a wave equation in terms of, the easiest way to do it is in terms of electric field, because we know an equation has to be 1 over 2 the average wave intensity equal to 1 over 2 C epsilon naught E squared. So there's an equation that relates S or I guess it's I because I wrote it I over there, I with the electric field, and the rest is constants. So we can directly the electric field from this equation, E, solving for E, 2I over C epsilon naught, where c is the speed of light, 3 times 10 to the 8 second. C is the speed of light, per second, and epsilon naught is the permittivity of the factor, which is 10 to the negative 12. So solving for E, using the equation, solving for E gives us E is equal to, which is, this is E max, by the way, 184.1. 184.115. The units is newtons per coulomb because the field is defined to be F over Q, force, or charge. Now to construct the wave equation, we're going to do it in terms of E. Remember that E of x t is just as the electric field is a function of the position and time. E of xt is equal to E max, either cosine or sine. We're going to fill this in a bit. Well, I'm going to write it down and okay. I'm going to write it down differently. I'm going to say, actually for now, we'll just do square number kx minus omega t. We'll change that in a bit, or we'll elaborate a bit more on that. Now, we know that at t equals 0, we know that the electric field E is equal to E max, right? T equals 0 and also x equals 0. So we know that sine of 0 is equal to 1, which is max at 0. That tells us that the function that we're using for the wave is actually a sine function, and not a cosine. Oh, sorry. Cosine of 0 is equal to 1, not sine of 0. Silly me. Okay, so what I want to say about this wave equation here, what does this actually mean? So the original form of it, which tells us a little bit more about it, is 2 pi over lambda. All this is multiplied by x minus vt. So when we distribute it, pi over lambda we know is k, right? And 2 pi over lambda times v times v equals omega. What does this actually mean, though? So this is an x-axis. X is the point at which the particle is at. So if you have a moving particle in a dimensional space and it's moving along the x-axis, for example, it's moving at a speed v, and it's at a position x. We know that it's going to be given, the equation of its motion is going to be given as x plus or minus vt, depending on the direction it's moving. Now, if you think about this, cosine of x in the xy plane looks something like that. Now, if you introduce a phase angle, let's say cosine of x minus v, the new graph of the cosine, because at x equals v, cosine of v minus v is equal to 1. So if this is your phi, that's your phase angle, and the cosine is going to look something like that. So the entire cosine was shifted to the right an amount phi. Now in our case, when we say that the wave equation, it looks something like cosine of some constant that I'll talk about a bit later, this is changing, and this is changing. Now for a fixed value mass, when t changes, all that's going to happen is that this graph, this red graph, is going to be moving either in this direction or in that direction. In this case, it's going to be moving to the right in that direction, because we just saw that as E grows, this graph is shifting more to the right. Now, what's left? So, why do we multiply by this constant? So pi over lambda, because remember, the units for x is meters. Units for vt, v is just the speed of the wave, so v is actually the speed at which your sine graph is moving to the right. Or cosine graph in this case, is moving to the right. So v of t is just also meters per second times second meters. 2 pi over lambda, you can think of 2 pi over lambda as a scaling factor. It's just a scaling factor from meters to radians. So it's just radians. It's just meters. So, in fact, 2 pi over lambda is just saying that because we know that if this is a wave, this is its lambda from the beginning to the end, and t is the time for one period. So the time it takes the wave to move from here, so it's the time it takes the wave to go from here to this situation. Assume that each one is different variables. So I mean there's going to be a different way. Let's try to color it with a different color. And this was here. You know, the time it takes the graph to go from this situation to this situation is t0, the time for one period. So that's why when we do 2 pi over lambda multiplied by dt, we're going to get 2 pi p over lambda mt. And remember, since we just said that t0 is the time for 1 lambda, time it takes away to move 1 lambda, that means v over lambda is equal to 1 over t0. Maybe you can look in a different way, this might be a little bit confusing. Just multiply by lambda v over lambda. V is equal to lambda over t0. So that's the distance, which is 1 wavelength in 1 time period. That takes it t0, a period to over distance lambda. And if you plug this in here, you're going to get 2 pi over t0 is equal to 2 pi f, which is equal to omega. And we had a t original equation, so it's omega t. That's why our wave equation is kx, k, which is 2 pi over lambda minus or plus omega t, cosine or sine of that. So anyway, that's just a little bit of an explanation of how we got this equation or how we got the other one from this. Now, to go back to the original problem where we said, I'm just going to erase this. So this is the equation that we'll be using. Let's say E again in this form E max and cosine 2 pi lambda times x minus vt. Now we know that v, we just said that v is the speed at which the wave is moving, and we know that. We already know that v is equal to c, which is the speed of light, which is 3 times 10 to the 8. T is a variable because lambda is a function of t. This is a variable as a function of x on this given. And from this, we can find E. We have E of 0, 1.5 nanoseconds. Because they say at the origin, at time t equal to 1.5 nanoseconds. So that's just going to be E max, which is what we have. We already found E max, it was 184, I believe, or something similar to that. And 2 pi lambda, actually, we don't need to evaluate this, do we? No, we do. Not for the first part, though. This is kx, but x is 0. And the second part is 2 pi over lambda v. V is c. T is 1.5 nanoseconds. You know, pi over lambda is 0.3, but it's given. C is the speed of light, 3 times 10 to the 8. V E max is what we just found, and this gives us E equal to negative 184, actually. Negative 184. 84. Figures. So this just tells us that at this time, we're just going to draw the X, Y, Z axis. We know it's moving in the positive X direction. It's moving in the positive X direction. This is a pointing vector X. At a certain time, which is the 1.5 nanoseconds. It looks something like that. We know that E cross B is supposed to give us S. So E cross B gives us S. That means at this time, we're going to have our magnetic field pointing in the negative Z direction. So we know the direction of it. So I'm just going to write that the direction of B of Z is equal to, or B of Z is in K hat. Let's see, hat K hat. So from the value E is to, was it E over C gives us B, yeah. E over C is equal to B. So 184 over, notice there's an angle here, over 3 times 10 days of flight gives you 6.1 ish. And since the original question asked for U of Z, this is going to be negative of the magnitude. Because it's in the, we already established that negative Z direction. Like that. Negative Z direction. Negative K hat. Okay, that's it for this question.